Hi students, Mr. Myers here. Sorry I can't be with you today, but I wanted to take a moment and go over what you're going to be doing in class today. First, attendance should have been taken, and then secondly, as you came into the classroom, you should have retrieved your assigned Chromebook, and then gone on to Google Classroom to take that fun survey about baby beta, as we were talking the other day. Now, at this point, you should have received the Gizmos activity titled Balancing Chemical Equations. It looks a lot like this, except I have the Google Doc version. And then now you're watching the tutorial video that I'm making right now. In this video, I'm going to go over some of the instructions and pre-lab material that I plan on doing in class with you guys, but I'm not able to do. So after that, or after the video part, you'll go to www.explorelearning.com. This is the site for Gizmos that you logged into last week. If you're in second hour, there are a couple of you here who did not get the chance to log in because you were sick or out of town for Thanksgiving break already. So second hour, this is your class code, and the sub should provide that to you if needed. It is case sensitive, so include the capitals. Fourth hour, if you're watching this, you do not have to do this because everyone already logged in before break. I already checked. Okay. So here is the activity. Here's some of the vocabulary that you need to be aware of. Okay. I'm going to choose a color and that. And so all of this here, you should be familiar with already, like what a coefficient is and what a subscript is, what a compound is, and the different reaction types like decomposition, double replacement, single replacement, synthesis, even a combustion reaction. I'm just going to put comb. I guess that's the best I can do on the mouse pad here. And as well as knows, element, molecule, compound, product, reactant. A lot of these are already in your vocab sheets from Monday. So if you need to go back and relook at these to understand what they are, then that would be a good thing to do. All right, so then the Gizmos warm-up that I was going to do with you. It says here in a chemical reaction, reactants, which are our starting materials, those interact to form products. Remember, reactants react to yield or form or produce products. This process is summarized by a chemical equation. In the balancing chemical equations Gizmo, which you're using, so if you're at Gizmos and you're already logged in, what you'll do is you'll see that there are two here, balancing chemical equations and chemical equations. You are choosing this first one, the balancing chemical equations, and you're going to launch it. So go to launch. And it looks like this. Okay. So the sheet says, looking at this, we're looking at this initial reaction. Hydrogen plus oxygen yields water. And so what we need to identify is how many atoms are in a hydrogen molecule. So molecule is the component, the substance there, but how many purple dots do you see present? Now your sheet, it's in black and white, so the darker gray, I believe, is the hydrogen. And you should hopefully see that there are two there. Okay. And then we ask how many atoms are in an oxygen molecule. Well, one oxygen molecule has a subscript of 2 there, so there are 2 oxygen molecules present. And then asks how many hydrogen and oxygen atoms are in a water molecule. And again, this is atom counting that we had the other day. So I'm going to clear those, and we had 2 there, 2 there, and hopefully total atoms, there are 3 atoms total, but there's 2H, and there's 1 oxygen. Okay, so a total of 3 atoms there, 2 hydrogen, 1 oxygen. So then in general, what does a subscript such as the 2 and H2 tell you about the molecule? Well, as we indicated above, it tells you how many of the atom there are. So the 2 in hydrogen tells us how many of the preceding or coming before atom there are, which is 2 H's. Now in 5, a chemical reaction is balanced, keyword, if the number of each type of atom on the left side is equal to the number of each type on the right side. All right, and this is getting at a huge idea here, which we call the law of conservation. Now, let me clear this. I can do this a little bit easier here. I'll close that right there. It's the law of conservation of matter. Okay, so this here, law of conservation of matter, is where we can either create or destroy matter in any chemical or physical change. So effectively, the number of atoms that we count up on the left side of the equation must equal the number of atoms on the right side of the equation. Now they can change forms. So like in our equation up here, we have 2 hydrogen atoms, 2 oxygen atoms. We need to make sure that the number of each adds up to be the same as the number on the right side of the arrow. That's what balancing equations consist of. Okay, so activity A today is balancing equations. You're going to get the Gizmos ready. It should already be launched. And you're going to check that the synthesis reaction is selected. So synthesis here is selected. And that all coefficients are set to 1. 1, 1, and 1. Okay. So the intro, the equation H2 plus O2 yields H2O is unbalanced because there are 2 oxygen atoms here on the reactant side, but there's only 1 on the product side. So that's not equal. We have to fix it. To balance it, you cannot change the structure of any molecules, which means you cannot change the subscript. But you can change the number of molecules that are used, and that's where the coefficients come in. Okay, that term up here, coefficients. That's what we can change. So at this point, how are chemical equations balanced? Well, you're going to go through and practice. So you're going to balance by showing histograms, which is here. And we can see the H's are equal, but the oxygens are not. So you need to figure that out and adjust either by changing the number up here of hydrogen molecules, or you can adjust here and change the value that's presented. Okay. When you're all done, you go to show summary to see if your equation is balanced. If it is, you'll have I think a green check mark. Okay. Solve, you're going to turn off show summary, and then you're going to choose reaction. Check these, check your answers, and see how you do. And then step 3 here is balancing the following equations. These, my hope is that you can do these by hand, by checking to see if each atom is added up on each side and just working through it. If, however, you want to use the computer to do this, you would go back to your class on Gizmos and go to the chemical equations. And what's cool about this one is that you can input any reaction you have, and it will put it here in the green bar, and then you can work on balancing it. For example, Na plus Cl2, so it shows us a sodium and 2 chlorines, yields NaCl. And so right now we can see things aren't equal. So if I have 1 sodium on the left and I have 1 on the right, those are good. But notice you have 2 chlorine on the left, 1 on the right. So we need to put a 2 coefficient in front. And now the chlorines are equal, but what's happened is we've doubled the sodiums. We have 1 on the left, so we must go back and put a 2 in front of the sodium. And now what you can see is that we have 2 of each on both sides. So it is balanced, and it tells us so. You can also change this to numerical. You can change it to histogram. Same thing on the other side. And we're going to stick with atom count there. Okay, so this is another tool that you can use while working through this. Your goal for today is to get through all of activity 1. And if you're able to, jump ahead to activity B, which we will continue in class on Monday along with additional practice. If you do make it to B, you are both balancing and identifying the reaction type as shown for more practice. Okay, there is no homework this weekend unless you want to print off balance and equations practice set from Honors 1 class website, which looks like the following. If I go to the website, go to Honors Chemistry 1, Unit 5, Chemical Reactions. And then there's a few different balance and equations things here. Like you could do balancing chem equations, that first one. And it's definitely more balancing, a lot more balancing here. But you can also, to the right or to the left of it, identify the reaction type for more practice. Okay? With that being said, hope you guys have a great weekend and a great time in class here.